Hello, this is chapter 4 vocab, and here we go with the first word. This is Mrs. Fresco. First word, linear model. A linear function that models a real life situation. Anytime you see this word model, that's the important part. Model means that you're going to apply what you're learning to a real life situation. That's what mathematicians do in real life, is they use math to model things that are happening in the world. An example here, many repair people get paid by a linear model. The parts are a set amount of money, the person gets paid so much every hour. So maybe they're going to fix your car and they're going to say, okay, well, the parts are going to be $100 and then you're going to have to pay us $20 every hour it takes us to fix it. That, if we graphed that concept, it would come out to be a straight line. Second word, point slope form. This is another form of a linear equation, and it's written when you know one point and the slope of a line. So it comes from the equation for slope, and it looks like this. So if you have these 2 points that are 2 points on the line, these 2 points that are 2 points on the line, and the slope, then you can plug these numbers in and write an equation for it. So if you knew what your 1y was, you could put it in here for 1y and 1x if you knew what one coordinate was. And then if you knew what the slope was, and then we could have a nice equation that leaves us with 1x and 1y that we're looking for. You'll learn more about that. Just know it's a linear equation with 1 point and the slope. Next word, hit pause if you need to. Parallel lines. Two lines in the same plane that never intersect. Hopefully you know parallel lines. This red one and this blue one are parallel. We'll talk about what makes them parallel. Why will they never meet? What's interesting about their equations? How will we be able to recognize them? So parallel lines, two lines that are in the same plane, meaning they're both flat, that never intersect. Hit pause if you need to. Next one, perpendicular lines. So perpendicular lines are two lines in the same plates that intersect at a 90-degree or a right angle. Now some of you might not understand degrees and angles very much, and that's okay. The big idea is that this right here, boom, boom, they meet at what's called a right angle. So it's like streets that are crossing each other. Okay, and it's 90 degrees. You guys should know enough about angles to understand that. They'll be straight, vertical, and horizontal from each other. Not necessarily vertical and horizontal like these guys aren't, but in relation to each other, one side to side, the other one will be straight up and down. Okay, that little symbol that I just drew there is for a 90-degree angle. Okay, next one, scatterplot. We're going to be doing scatter plots. I love scatter plots. A scatter plot is a graph that shows a relationship between two sets of data. So for example, here it's the temperature outside and how much ice cream a store is selling. And they're looking to see, well, is there some sort of relationship between the hotter it is out and how much ice cream we sell? So you could collect some data and you would put it on a scatter plot, and each of these points is one piece of data that you collected. Okay, the two sets of data would be temperature and sales. There's got to be two things that are changing. Okay, next one. So when you have a scatter plot and you plot them, you look for what's called a correlation. And a correlation is a relationship between the two data sets. Key word here, big time word, is this relationship. Is there something going on between those two? You can have a strong positive, just a positive, a negative, or no correlation. We'll go over these a lot more, what it looks like to be strong and stuff, but I'm just showing you that sometimes they kind of end up in a line, sometimes they're all over the place. So we'll be looking at if there's any correlation, we'll use this word a lot, between the two pieces of data. Okay, hit pause. When you do a scatter plot and you plot all those pieces of data, you put down what's called a line of best fit. And it's a line that kind of goes right in the middle of all the data pieces, and we use that as a model for the set of data. So now we could use this line, get the equation for the line, make predictions, do stuff like that from the scatter plot. So a line of best fit is a line that best models the set of data. You should be able to do this one on the test, because look, line, line, best, best. Okay. Next word, correlation coefficient. Now that's a big one. Coefficient is a number. You should know that word, coefficient. And a correlation coefficient is a number. So it's a value R that tells how closely the equation of the line of best fit models the data. So it kind of tells you how strong your data is, how well we can use it to predict. If it's not very strong, we'll say, well, I wouldn't, count on this to always be true. If it's a really strong correlation, then you can make predictions and say, I just almost for a fact know this is going to be true because we have such a strong correlation. This we'll put in our notes later. You could jot it down if you want, but you might not understand this quite yet. It just shows that 0 is there's no correlation, and the numbers go between -1 and 1 for the correlation. But remember, you just need to know the definition for right now. Okay, here's my, some of you guys might feel like this. I always try to tell you why, learning algebra is a good thing. But I know some of you feel this way. And when I was in 8th grade, I probably felt this way too. So that just made me laugh. There you go. Okay, I believe this is last page, or we might have one more. Sequence. They're nice and short though. Look at these. Not many words to these. Sequence is an ordered list of numbers. And so it's a list of numbers. That's cool. And then it has to be in some sort of an order. There has to be a pattern to it. So both of these guys are sequences, but they're very different sequences. If you look at the pattern and how they're changing, they're very different sequences. But they're both sequences. They're a list of numbers and they have some sort of order to them. They're not just random. The term, a term in this setting, okay, because we'll use term a lot for different math things. A term, as far as a sequence goes, is referring to each number in the sequence. So we'd call this guy the first term of the sequence, the second term, the third term. Okay. Go back, hit pause if you need to. Last page here. So we talked about sequences on the last page. Here was sequence. Well, now there's an arithmetic sequence. You say this arithmetic. Arithmetic. It's a hard one to say. Arithmetic sequence. And this is another ordered list of numbers, but in which the difference, and that's a big keyword there, highlight it, I love my highlighter, the difference between each pair of consecutive terms is the same. So think about difference. Do you think add, subtract, multiply, or divide? Usually with the word difference, you think of subtracting. And that's the idea here, is if I go from 5 to 8, I would subtract 8 from 5 and say, oh, the difference is 3. So when you have the same difference, adding and subtracting, where you're going up plus 3, plus 3, plus 3, plus 3, that is an arithmetic sequence. So this guy right here, we could say, yes, this one's arithmetic. Okay? This one is not arithmetic down here because this guy does not add or subtract to get from 1 to 2 and to 2 to 4 and to 4 to 8. It multiplies. Times 2 times 2 times 2. This is not arithmetic. This one is arithmetic. So the change from one to another, you have to be able to find by subtracting the difference. Taking 8 minus 5 and you get 3. 11 minus 8 and you get 3. Okay, this could also be a negative where you're going down by 3, down by 3, down by 3, and that's still arithmetic. But if you're multiplying or dividing, then that's not arithmetic. It's a really big deal with the idea of difference. Last one is a common difference. So the difference between each pair of consecutive terms in an arithmetic sequence. So if this is my arithmetic sequence, the common difference I say is 2, because that's the difference between 2 to 4, 4 to 6, 6 to 8. All of them change by 2, and that's called the common difference. So I could ask you questions. What's the common difference between the first term and the second term in this sequence? Ooh, that's a lot of vocab words right there. And you could say the common difference is 2 between the first term and the second term of this sequence. Okay, good luck. I think that's it. Yep. We'll talk to you guys later. Have this done on time. 9 minutes. Wonderful. Bye. Bye.